simplify each expression. Use positive exponents. For part A, x to the 6th times x to the negative 4 times y cubed. In this case, we're going to use the rule that says when we're multiplying two exponential expressions that have the same base, in this case x, we add together their powers. So this is equal to x to the 6 plus a negative 4 times y cubed. We add 6 plus negative 4, and that's equal to 2. So this is equal to x squared times y cubed. Since x and y are different, the bases of the exponential expressions are different, and this is as simplified as it can be. For part B, we have the fraction 16 times x to the negative 2 times y to the 8th. All of that divided by 6 times x times y to the negative 7. When we deal with fractions that have both constant terms and variable terms, we deal with the constants by themselves. In other words, we have 16 divided by 6. We can reduce that. Each of these is divisible by 2. 16 divided by 2 is 8. And 6 divided by 2 is 3. Now, in terms of the variables, when we are dividing variables, we actually subtract their powers. And as I look ahead, since we want to use positive exponents, I am going to put the x in the denominator. So let's extend this. And remember, this is like x to the power of 1. So this becomes x to the 1 minus a negative 2. That will eventually create a positive power for x. Now the y's, as I look at them, I will do it and keep it in the numerator because I'm going to subtract the powers of 8 minus a negative 7. So now we can simplify this. In the numerator, 8 minus a negative 7 is really 8 plus 7, and 8 plus 7 is 15. So in the numerator, we have 8 times y to the 15th. And in the denominator, the 1 minus a negative 2 is like 1 plus 2, which of course is 3. So that's 3 times x cubed. And our final answer then is 8y to the 15th divided by 3x to the 3. For part C, we have the quantity 2y z to the negative 2 in parentheses all cubed. Inside the parentheses, we can simplify the z to the negative 2, and this becomes 2y over z to the positive 2. And we have that entire quantity cubed. Now we apply the fact that the cube needs to apply to both the 2 and the y in the numerator, and it applies to the z in the denominator. So this becomes 2 cubed times y cubed over, well now z squared cubed, recall that the rule when you're taking an exponential expression and raising it to a power is that you multiply together the powers. So this becomes z raised to the 2 times 3. When we simplify this a little bit further, 2 cubed is 8. Y cubed remains as is, and in the denominator, 2 times 3 is 6, so we have z raised to the power of 6. So our answer is the fraction 8y cubed over z to the 6th. For part D, we have the fraction 15x to the 4th divided by 10xy to the negative 2, that quantity raised to the negative 2 power. Let's simplify what's inside the parentheses first. So, in doing so, we have 15 over 10. Each of those is divisible by 5. 5 into 15 is 3, and 5 into 10 is 2. Now, in terms of the variables, we have x to the 4th divided by x. That becomes x cubed because we subtract 4 minus 1. For the y to the negative 2 power, remember we can put that into the numerator and change its power to positive. So that's what's inside the parentheses, and that's raised to the negative 2 power. Well, remember, when we are raising a fraction to the negative 2 power, we can take the reciprocal of the fraction, so this would be 2 over 3x cubed y squared, and we raise that to the positive power, in this case, to the power of 2. Now we apply the 2 to the numerator, and that's 2 squared. And we apply it to each of the factors in the denominator, so it becomes 3 squared. Then x cubed and then squared, we multiply those powers. So it's x to the 3 times 2. Similarly, y squared and then that whole expression squared, we multiply the powers 2 times 2. Simplifying it now, for our final answer, we get 2 squared, which is 4, and then we divide that by 3 squared, which is 9. X raised to the 3 times 2 is x to the 6th power, and y to the 2 times 2 is y to the 4th, and that's our final answer.